Now, in our previous video, we talked on function of a function, where we say dy dx is equal to dy du multiplied by du dx. Okay, and we took about 4 examples on it. Now let's take special examples on this. Let's say y is equals to 5 exponential 2t plus 1. Now we are asked to differentiate this with respect to t. Recall that when it comes to the exponential function, differentiating with respect to t of e raised to power at will give us a exponential at. Now, in this case, we can make this equal to u. Therefore, we say u is equals to 2t plus 1, and therefore y will be equals to 5 exponential u. Now we can evaluate dy du, and we can also evaluate du dt. Du dt is equals to 2, and dy du will be 5 exponential u, because when we differentiate exponential u, we will have exponential u. Now, our dy dx or dy dt according to the formula will be dy du multiplied by du dt. And our dy du is 5 exponential u, and our du dt is 2. And this is 10 exponential u. And we will make our substitution of u back. We have 10 exponential 2t plus 1. Let's take another example. 2. Given y is equals to 2 divided by 2t cubed minus 5 divided by 4. And you can pause the video and give this a try. Alright. In the law of indices, we know that when we have 1 divided by exponential x raised to power n is equals to x raised to power minus n. Okay, so this can be rewritten as 2t cubed minus 5 raised to power minus 4. Now in this case, we can say let u be equals to t raised to power 3 minus 5, and therefore our y will be equals to 2u raised to power minus 4. Therefore we can evaluate dy du, and we can also evaluate du dt. Dy du in this case will give us minus 8 u raised to power minus 5, and du dt will give us 6t squared. Therefore our dy dt is equals to dy du multiplied by du dt. That is minus 8 u raised to power minus 5 multiplied by 6t squared. So having done that, we have it to give us minus 48 t squared u raised to power minus 5. Now we can rewrite this to give us minus 48 t squared u raised to power 5, because we have applied the law of indices. Now substituting our u back, we have that our dy dt is equals to minus 48 t squared divided by 2t cubed minus 5 raised to power 5. Let's take two more examples. Now, Function of a function can become a little bit complex when we have questions like this. Y is equals to 2 exponential tan theta. 2 exponential tan theta. Now this is very easy. Let's just apply the principle of function of a function. So we say let u be equals to tan theta. Therefore our y is equals to 2 exponential u. So with this we can evaluate the y du, and also we can evaluate the u the theta. Okay, so the y du, when we differentiate it, we'll have 2 exponential u, and when we differentiate tan theta, remember that differentiation of tan theta or tan ax of tan ax is equals to a sec square ax. So differentiation of tan theta will give us sec square theta. Therefore our dy the theta will be dy du multiplied by du the theta. And our dy du is 2 exponential u, and our du the theta is sec square theta. So this is 2. Let's substitute our exponential, our u, as tan theta, and sec square theta. Finally, as we wrap up on this, let's take another example. 6 tan 3y, 3x plus 1. Now we can say our u is equal to 3x plus 1, and our y will become 6 tan u. We can evaluate the y du just like we can evaluate the u dx. Now evaluating the y du, we have 6 sec square u, because differentiating tan u will give us sec square u, and differentiating 3x plus 1 will simply give us 3. Therefore our dy dx is equal to dy du multiplied by du dx, and that is 6 sec square u multiplied by 3. That is 18 sec square u. And substituting our u back into the answer, we have 18 sec square 3x plus 1. Now we will notice a little bit that when we are doing, let's say, the y the theta, the y the t, and the y the x, as we wrap up on this video. And in terms of function of a function, the first is always the y du, the y du, the y du, which is being multiplied by something. And now what is it being multiplied with? In the case of the theta, it is being multiplied by du the theta. In the case of the t, it is being multiplied by du the t. And in the case of the x, it is being multiplied by du dx. So this brings us to the end of function of a function. And in our next video, we will talk about successive differentiation, where we are asked to differentiate a function twice, or probably 3 times, and it might be up to any number as possible.